Hello guys, welcome to ICM Education Portal on YouTube. I am Shrutadip, your peer educator for today, and I will be teaching you Math 1500 and our topic will be mean value theorem. So without any further delay, let's start.
So as I told before, our topic is MVT, so which is actually in elaborate from mean value theorem. So let's start with Rolle's theorem. So what is that actually? It is actually not MVT, be sure about that, but it will make the thing easier. So what is it? Suppose that fx has a derivative on the interval AB and is continuous on interval AB. So be careful about this one is closed interval and this one is open interval. Okay, so whenever we will have the first bracket like this is open interval and this one is closed interval. Okay, and function of a equal to function of b, and then at same value c is element between a and b, but it can be a b, because it's open interval. So it basically means that a is less than c and c is less than b. That's it. Okay, so then the differentiate function of c is 0. Okay, so that's actually Rolle's theorem. But what's the difference between Rolle's theorem and MVT? So from here to here, everything is okay. Everything is okay. Then we said in Rolle's theorem that differentiate function of c is equal to 0, but it's not the same here. So it's function of b minus function of a divided by the difference between the ranges, I mean b minus a. Okay, so what is it actually? If you remember, we have a slope, right? M. So m is basically slope of any line or any curve, right? So this is actually slope. If you look closely, so what is AB? This is y2, this is y1, and what is this? x2, x1, right? So this is basically y2 minus y1 divided by x2 minus x1, right? So this is m. Simple as that. This is m. Okay, remember that. So it will like help you to remember this formula, right? In this form, this is very hard to remember, right? So if you think about slope, if you think about that it's just a m, then it will be easier for you. And one more thing, this theorem is also called as Lagrange's theorem. Okay, but you don't need to remember it, but yeah, you can have a look there. So for MVT theorem, we have exactly two conditions. What are those? Number one, f is continuous on the closed interval, as I told you before that this is closed interval, right? And the other one is f is differentiable on the open interval. So this is open interval. Okay, so we need to focus on continuous and differentiable. If these two conditions are satisfied, then what can we say? We can say that then there exists c in AB such that what? Differentiate function of c equal to m. And what is m? fv minus fa divided by b minus a. That's it. Now for differentiable, if we can differentiate it, if we make a differentiation out of the function, then obviously it is differentiable. Let's say 4x cube plus 2x plus 3. This is fx. Then what is its differentiate form? It's 12x square plus 2, right? So you see, if we find the differentiate form, then obviously it's differentiable. I can find it its differentiate form, so why it cannot be differentiable, right? Now then what about this continuous? So what is a continuous function, guys? Remember that this is very important, because if you can satisfy these two conditions, you can go further in this math. Okay, so these are the things we can call as continuous function, but there are some subnodes. Okay, so this one, polynomial function, this one is always continuous, always. That means the domain is R. That's basically minus infinity to positive infinity. That goes for polynomial function, but it's not the same for the other one. It's not the same for rational, it's not the same for exponential, it's not same for root, trigonometric, logarithm, and inverse trigonometry. In order to make these crosses right, we can say that, let's say domain is a to b. If the functions are belong to this range, then we can say that this rational function is continuous in this domain, this exponential function is continuous on this domain, like this. And you may ask me what is a rational function, right? So it's basically just the division of two other functions. So if you call it as fx, then this one is rational function, right? I don't think that you need the explanation for the other ones, but if you wanna look over there, then yes, you can just google it or you can find it from anywhere, right? If you have any doubt about it, you can also ask your teacher or instructor. Okay, that's basically all about the concept part for this MVT. Let's do an example. Okay, so let's see what we have. Okay, before starting, I should say that difficulty level is here medium. Okay, what does it say? It says verify the function fx, which is this one, 4x cubed plus 7x squared plus 2x minus 3, satisfies the hypothesis of the mean value theorem on the interval. What is the interval? 0 to 4. 0 to 4. This is closed interval. Okay, then find all numbers C that satisfy the conclusion of the mean value theorem. Okay, let's do it together. So let's write down the functions first. So what is the function? I better use the black one. Okay, 4x cubed plus 7x squared plus 2x minus 3. And what is the range? 0 to 4, I mean Roman. Okay, firstly we need to, what's that, we need to satisfy the conditions, right? So what is the first condition? We need to prove that this one is continuous on this domain. Okay, so you see, this is polynomial. Definitely it is continuous on this domain because it's continuous on every domain, right? Minus infinity to positive infinity. Okay, since the function f is a polynomial, it is continuous on 0 to 4. So for continuous, we have closed interval. Remember that. For continuous, we have closed interval. Continuous, closed. And for differentiable, this one is open interval. Okay, remember that, very careful about that. Okay, so thus we can say that the first condition of MVT is satisfied, right? Satisfied. Okay, fine. Then what about differentiability? So if we can differentiate it, then it's obviously differentiable, right? So let's see whether we can differentiate it or not. So yeah, I think we can, right? It's 12x squared plus 14x plus, okay, 2. Good. Then what? Then f is differentiable on 0 to 4. As I said, for differentiability, it's open interval. Okay, thus the second condition of MVT is satisfied. For implementing the formula, we need two things. That one is function of the lower limit and function of the higher limit, upper limit, I mean. Okay, be careful that this one is not connected to this one. Okay, and also this one. No, never, never. This is not this. This and this are not same. Okay, okay. If we put 0 here, this is minus 3. And what about this one? So yeah, so 4 into 4 cube plus 7 into 4 square plus 2 into 4 minus 3. Okay, yep. Then what? Then 256 plus 112 plus 8 minus 3, 373. Okay, fine. Then we can now use MVT formula. So according to MVT, there exists C in 0 to 4 such that fc equal to f4 minus f0, 4 minus 0. Okay, 12c square plus 14c plus 2, 373 minus 3. Okay, 4. So this one is this and this one is this, right? We just did plug in here. Okay, so then 6c square plus 7c plus 1. So I actually have 2 here, so I better put it here, so into 2. Okay, so this one is 376. Now what I have, plus 1 equal to 47, 6c square plus 7c minus 46, 0, right? So now you can see that this one is very complicated to find out the root, but what do you know, x square plus bx plus c equal to 0. For this form, x equal to minus b plus minus b square minus 4ac root over divided by 2a. So yeah, we can apply that here as well. So minus 7 plus minus 49, 4.6 into times this one, this, and 2 times 6. That means plus minus 49 plus 1104 and 12. Yeah, minus 7, 1153. Okay. Yeah, we are done, right? Something is fishy. Okay. What is that? That we need to check for the, for the domain. We have 2 values here. So one is minus 7 plus root over 1153, and another one is minus 7 minus 11 root over 1153, 12. Our domain is 0 to 4, so it should be the first condition. What is it? It can be negative. Negative, not acceptable. We can see this one is obviously negative, so this is not acceptable. But this one, how can we be sure this one is not negative? Because if this one is higher than the root term, then it can be negative, right? But 7 means what? This, right? So this is definitely lower than this. Okay, so c equal to minus 7 minus root over 1153 over 12 is not acceptable, right? Acceptable. Why? Since minus 7 minus root over 1153 over 12 does not belong to the domain 0 to 4, right? So the required c is equal to minus 7 plus root over 1153 divided by 12, and this is our answer. Okay, then what about this one, where domain is minus 3 to 3? So let me ask you, is this possible to do it? Okay, to be sure we need to check with the conditions, right? So what was the first condition? Continuous. So yeah, like mode functions are continuous, right? So what will be the graph? So for this on the graph will be look like this. So we can also show minus 2, that is this one, because y equal to x minus 2. So if x equal to 0, that means y equal to minus 2. So here minus 2. So this is continuous. We can find everywhere any point, right? So yeah, first condition is satisfied. Then what about the second one? Differentiability, right? Okay, so is this differentiable? No, mode functions are not differentiable, because for this case it's x minus 2, and for this case the fx is minus x minus 2 the whole. So we can differentiate the function which has 2 forms in 2 types of range. Okay, so it's not differentiable. Then what? Then this one is not applicable to find out the C. Not applicable. Okay. So that was pretty much about this topic, and now I have something for you so that you can test yourself. Okay. Yeah, this one is for you to do on your own. So remember that difficulty level is what? This is hard. Yeah, you can figure it out, and just don't skip the video, or like I encourage you to pause the video here and just try it on yourself. So yeah, try it. I hope you are done with your test. So here is the solution, guys. Okay guys, I can guess that many of you wasn't able to solve this one, but you tried. That's what the best about your effort. So don't need to be hopeless, because whatever you tried, you learned it, right? So have a look over there, so how to solve this, and you need to do practice more and more. Yep, that was MVT. If you have any question, you can just book an appointment with peer educator, and also I will be putting some, you will find some links under the YouTube video, so you will go there and study on your own. Yeah, so now I need to say goodbye. So yeah, best of luck on your exams and other stuffs, and also for your better future.